Okay, so the very first thing we're going to put on our unit circle is we're going to draw our X and Y axis. So just extend these out. This is technically not one of the colors. This is just a visual here.
Pencil pouch me. Did you hear my voice crack?
Now, because obviously a circle can go any way, you may want to go ahead and write X and Y on here just so that it's obvious of which way we did it. Alright, so I'm going to choose my first color, and we're going to be drawing on the innermost part of the circle in here. Okay, something else is going to go on the outer part of, inside the circle. So I would recommend you do this like I do. So the first thing that we're going to be putting on here is degrees. So we've been talking about radians and degrees. So degrees is going to be the first thing, then we're going to do radians and all of that. So if you memorize degrees, it would take you a long time, but you could convert all the values using pi over 180. However, you're not allowed to have a calculator on the unit circle quiz. So you'd have to just figure out what it is by reducing. But you can determine all the radian values if you know your degree values and you know your conversion factor. It would just take you a long time. So we start with 0. That's the most commonly missed thing on the unit circle, is 0 degrees. People forget to write the 0. Why, I don't know, but it's what happens a lot. So then you see these smaller pieces here. So the ones that are farthest apart, that's a 30-degree increment. Then there's 15 between each of these, and then 30 to the next one there. So this first line here is 30 degrees. This next line is 45 degrees. The next one is 60 degrees. And then straight up and down, it's a right angle, so it is 90 degrees. And then we keep going around. 30 more degrees is 120. Then these are 15 between them, so this is 135. The next one is another 15, so that's 150 degrees. And then all the way around over here, or halfway around, I guess I should say, is 180 degrees. So then I keep going down here, 210. The next one, add 15, so that's 225. Then we keep going, another 15 is 240. Opposite of 90 is 270. Another 30 is 300. Then we've got 315. Then I've got 330. And then the next most commonly missed thing on the unit circle is not putting under here 360 degrees. So you don't need to write this unless you just want to have the information. But when I grade, I'm going to write on your paper degrees, and I'm going to write the number of them that you have. The number of possible ones is 17. Okay, there are 17 degree values that are on the unit circle. So if you get all of those right, you get a 17, and you got nothing else, you get a 17 out of 64. Again, you don't have to have that, but I'm just telling you what that is.
Found a quarter.
All right, another color. Whoa. All right, so I'm going to do radians now. So I've done degrees. And again, as long as you understand the pattern, you can count them. Okay? And you don't even really necessarily have to memorize them. So over here, I'm going to do radians out this way, but still inside the circle. What?
Are we on a different color?
Yes.
Noted.
So, again, we start with 0. Which, again, why did it not change my color? What is happening? I chose it's a different color. Okay. So we start with 0. Again, for some reason, 0 gets missed. People get everything right and they forget a 0. Like, there's one person the other day, the only thing they missed was the zeros on the entire thing. I'm like, you memorized everything and you forgot a 0. They redid it and they remembered their zeros. But, huh? And if you go all the way to calculus, I don't reteach it. You just have to know it.
Oh, great. I'm not going there.
All right. So I kind of mentioned this a little bit as we were starting this section, the last section. But we can count out radians, obviously, in increments of what their denominator is. Okay? So it's based on how many sections half of the unit circle is broken into. So all of these are going to be the same color, but I'm going to go around and talk about them. So all the way, or let me say this, halfway around, so over here is pi. And then all the way around the entire circle is 2 pi. So the top section, I can break it in half at 90 degrees, right? That breaks it in half. So that would be pi over 2. So this is 0. This is 1 pi over 2. Finishing it around is 2 pi over 2, which reduces to pi. So everything's going to be counted this way. The next easiest one to do are increments of 45 degrees. How many sets of 45 degrees are in the top 180? How many? Every increment of 45 degrees.
4.
Yep, there's 4. So they're going to be pi over 4s. So at 45 degrees, it is pi over 4. Let's see if I can turn this brightness down a little bit. We're going to get there.
Give her some time, Jenna.
I'm just doing these ones first, and then I'll go back and I'll finish doing that. All right, so this is 1 pi over 4. This is 2 pi over 4, which reduces to pi over 2. Then this is 3 pi over 4. And then this is 4 pi over 4, which reduces to pi. And I'm going to continue going on down and around. So now, after that, I keep doing it as pi over 4. So this was 4 pi over 4, so this is 5 pi over 4. Then at 270, that would be 6 pi over 4, which reduces to 3 pi over 2. Then the next one is 7 pi over 4. And then all the way around one full time is 8 pi over 4, which reduces to 2 pi. So if I went back to my increments of pi over 2, I had 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Okay, but it's breaking up the top, like each section is broken up into that many pieces. Okay? Huh?
Are you going to do the eighths next on this?
There's no 8s.
Yeah, it's not.
All right, so the next one I'm going to do are increments of 60 degrees, and you'll see why once I go back and do 30 degrees. But increments of 60 degrees, how many sections of 60, so how many times can I divide 180 by 60? 3. So there's going to be 3 sections. So the denominator of that is 3. So
Oh, I see.
at 60 degrees, this is pi over 3. Now, then we have to go another 60 degrees. So this one skips pi over 2. This one skips this one. So we go over here at 2 pi over 3. Another 60 degrees is 3 pi over 3, which is pi. Then we jump another 60 degrees, and this is 4 pi over 3. Another 60 degrees is 5 pi over 3. And then all the way around is 6 pi over 3, which reduces to 2 pi.
Now do we have to go in the 30s?
Yep. So how many increments of 30 degrees are in 180 degrees? 6 of them. So these ones are going to be pi over 6s, okay? So these hit every 30 degrees. Some of them we've already done, obviously. But, so this one is pi over 6. Another 30 degrees puts me here at 2 pi over 6, which reduced to pi over 3. Another 30 degrees puts me up here at 3 pi over 6, which reduced to pi over 2. 4 pi over 6 reduced to 2 pi over 3. So then this is 5 pi over 6. And then 6 pi over 6 reduced to pi. Keep coming down, 7 pi over 6. Go another 30 degrees, that would be 8 pi over 6, reduces to 4 pi over 3. Then we come down here, 9 pi over 6 reduces to 3 pi over 2. 10 pi over 6 reduces to 5 pi over 3. 11 pi over 6 goes here. And then all the way around would be 12 pi over 6, which reduces to 2 pi. Now, you're probably like, she could have just told me what these values were, and I would have been okay with that. This is the reason I did it this way, so you can see how to count them. The other thing is when we are doing coterminal angles, this should make them a little bit easier for you now. Okay, as far as like going around, you can be like, okay, well, this is, this one's coterminal with whatever, and you can go all the way around to the next one. Okay. It'll also help you with like your conversions. Like there was one that we had yesterday, I think it was with arc length was in this class, right? All my trig classes get mixed up. So we did arc length, and we said that when we do that, theta has to be in radians. Well, one of them told you it was 60 degrees. Well, we had to use the conversion factor because you didn't know this yet. But now that you know this information, you could have just straight up told me it was pi over 3 instead of having to convert it. Okay, if it's a value on the unit circle, it's a known value, you can just do it that way. Okay, the next thing we're going to do, another color, is we're going to put our XY coordinates on here. Now, there's also, like there was 17 degree values, there are 17 radian values because this one has 2. The other things we're going to put on here are going to have 16 values.
17
Okay.
radian values.
Yep. So something you may want to note somewhere is that sine are y values and cosine are x values. Okay, that's not part of what you're quizzed on, but that's going to be helpful to you as we go about solving trig equations. So, a different color from what you've used so far. I'm going to put the values on here for the increments of pi over 2's. Okay? So, here on the x-axis on this side, the value of this point right here, okay, the unit circle has a radius of 1. So, this value here is 1, 0. Up here at pi over 2, it's 0, 1. Around at pi, it's negative 1, 0.
And then 0, negative 1.
Yep, and then 0, negative 1 down here. All right, swap colors again. All right, the next ones that I'm going to do are the pi over 4's because these are the easiest ones, okay? Both the x and the y value is root 2 over 2.
So we write that right there.
Yep, so that's your xy coordinate of that point, okay? Root 2 over 2 is approximately 0.707, okay? So it's a little bigger than half, a little smaller than the other value that we're going to get there. So if you, don't draw this, but if you came over here, you would see this is a little bit bigger than half. So if you forget what this value is, hopefully that you'd kind of remember or be able to visualize what goes there, okay? There's going to be 3 key numbers that you need to know for your XY values. Root 2 over 2 is one of them, okay? Every value that has a 4 in the denominator, right, because we counted around, pi over 4 also occurs here, but that doesn't have that. If you actually see the 4, it is the coordinates root 2 over 2. But what changes is the sign of it, okay? The SIGN, not like the trig function sign, okay? Based on where it is. So over on this quadrant over here,
Negative root 2.
x is negative, y is positive, so it's going to be negative root 2 over 2, positive root 2 over 2.
This kind of makes a lot of sense.
If you're a patterns person, this is pretty, it's not hard. If you're not a patterns person, then maybe I'll make you one. I'll turn you into a patterns person by the end. All right, then we come down here to 5 pi over 4. Well, x and y are both negative, so both of these are negative root 2 over 2. Then over here at 7 pi over 4, x is positive, y is negative. So this is going to be root 2 over 2, negative root 2 over 2.
Do you have whiteout? I wrote it in the wrong spot.
I don't think that I do,
Oh,
because I never use whiteout.
it's okay. I can make it work. I can draw an arrow.
Where'd you write?
I wrote it at the 4 pi over 3.
Well, imagine you write something there.
Well, we are going to be writing something there. All right, switch color again.
Switch.
Switch colors.
Purple.
I just got my blue. I want blue again.
All right, I'm going to do pi over 6s now. Really doesn't matter on these two. So the other two key numbers that you're going to need to know are 1/2 and root 3 over 2 as far as your x, y values, okay? So, again, don't draw this. I'm just going to show this for a visual for you to figure out how we know. So if I look over here, this value is, the x value is pretty close to 1, right? And then this y value approximately looks like it's close to halfway between. So that means that the y value is going to be 1/2. The x value is root 3 over 2, which is approximately 0.866. Okay, so this value here is root 3 over 2 and 1/2. And just like with the pi over 4s, all of the ones that are pi over 6s are going to be the same values. So 5 pi over 6, it's negative root 3 over 2, positive 1/2. At 7 pi over 6, they're both negative, so negative root 3 over 2 and negative 1/2. And then at 11 pi over 6, we have positive root 3 over 2, negative 1/2.
I hope this pattern doesn't have anything for me to do.
All right, changing colors again.
Let's pick red.
All right, now we've got the pi over 3s. So, if you visualize it, I told you that these are the numbers that we use. These are our 3 numbers that are like our key numbers. The pi over 3s are just a swap of the x and y values of the pi over 6s.
So half and then root
1/2 and then root 3 over 2, yep.
This is kind
Notice how I said that earlier.
So 1/2 root 3 over 2 is at pi over 3. At 2 pi over 3, it's negative 1/2 and positive root 3 over 2. At 4 pi over 3, both are negative, so we've got negative 1/2 and negative root 3 over 2. And then at 5 pi over 3, I've got
1/2 negative.
positive 1/2 and negative root 3 over 2. So again, there are 16 of those values that are on here of your XY coordinates. Okay, so the absolute easiest one should be the pi over 4s. Well, maybe the easiest one should be the x and y axis points, but the pi over 4 should be the easiest, and then you just need to remember which one goes with pi over 6, which one goes with pi over 3. And as long as you know something about a graph as far as where x and y are positive and negative, you should get the signs correct on those. Okay? Now, the next and the last thing we're going to be putting on here are tangent values. I used to teach this a separate day, and we would have separate unit circle quizzes that, like, you had to fill in just this stuff, and then we'd have another one where I tacked on the tangents, and I was like, why am I doing this as a separate quiz? Like, first of all, it's a lot for me to grade. Second, it's a lot for you to write. So why am I doing that? So anyway, so we're going to go ahead and put the tangents on here as well. There's going to be 16 of those as well, because everywhere you see a coordinate point that we've put on here, you're going to also have a tangent value.
How does yours look so much better than mine?
Because she's been doing this for a long time.
So tangent values, the way we find them, now you'll be memorizing these, but in general, if you were given a sine and a cosine value or an x and a y value, tangent is found by dividing y by x. So y over x. So if you're like, this is too much to memorize, I can't memorize 16 more things, you can sit here and solve for all your tangent values on your quiz with just some simple reducing, as long as you know how to divide fractions. Okay? So, once again, I'm going to tell you your pi over 4s are going to be your easiest ones. Okay? Because root 2 over 2 divided by root 2 over 2 would be what? 1. So this is, I'm going to do all the tangents in one color. We're going to choose this one. So all the tangent values of pi over 4 are going to be 1 or negative 1. You have to watch the signs. So positive divided by positive is positive. Positive divided by negative is
Negative.
So at 3 pi over 4, it is negative 1.
And then the next one is 1.
Negative over a negative is positive, so that's 1.
Oh, across from each other, they're positives and negatives.
And then at a negative divided by a positive is negative. So yes, so quadrants 1 and 3, your tangents are positive. Quadrants 2 and 4, your tangents are negative. Okay? On the axis, we'll deal with those in a minute. The next ones, or the next like easiest mathematically to solve, are the pi over 3s. Okay? So y over x would be root 3 over 2 divided by 1/2. So I'm going to write this out so we can see it. Root 3 over 2 divided by 1/2. I would not write this on here. If you want to do it on the back, you can. But this would be the same thing as root 3 over 2 times 2 over 1. 2's cancel, so it's equal to root 3. Okay?
Root 3,
So-
and you're switching the signs.
Root 3, and then same thing. So all of the tangent values in 1 and 3 are positive. All of them in 2 and 4 are negative. So at 2 pi over 3, it's negative root 3. At 4 pi over 3, it is positive root 3.
Oh, no.
And at 5 pi over 3, it is negative root 3.
Airball.
It's okay, I did that too. Not just that.
The next one's going to be the most difficult.
So then the last one mathematically is the harder one. Okay, so 1/2 divided by root 3 over 2. I'm going to go ahead and write out the keep, change, flip. So 1/2 times 2 over root 3. The 2's cancel, and I have 1 over root 3, but I can't have a radical in the bottom. So this is times root 3 over root 3,
Oh, is it just root 3 over 3?
which is root 3 over 3. Yep. And then the signs just change as you go around. So at 5 pi over 6, it is negative root 3 over 3. At 7 pi over 6, it's positive root 3 over 3. And at 11 pi over 6, it is negative root 3 over 3.
Interesting. This doesn't look as complicated as the people's in the years before.
Once you have a little bit of an understanding, it's definitely not as bad. But
It does stuff like that.
All right, so now I haven't finished putting all my tangent values. I still have 4 more tangent values that I have not done yet. Okay, we've got to do the axis points. So y over x. So this one right here, 0 divided by 1 is what?
0.
0. 0 divided by negative 1 is what?
0.
0. So on the x-axis, the tangents are both 0. On the y-axis, I have 1 divided by 0. What is that?
0.
No.
Wait, 1?
What happens when I divide by 0?
I am not sure.
If I gave you a slope and you ended up with a 0 in the denominator, what happens?
Oh, yeah.
Undefined. So the tangent value up here is undefined. Then on the bottom, negative 1 divided by 0. Undefined.
Dang, Jenna. Why couldn't you get that?
Why it's on June?
So if you're keeping track, there were 17 degrees, 17 radians, 16 xy coordinates, and 16 tangents. Okay,
I wrote them all.
that is all of it.
So what are
Okay.
the 2 extras?
Wait, you said 17 radians.
She's
Yeah, 17, 17, 16, 16.
And
I gave you some wiggle room to make a mistake because there's a lot of stuff on here.
Yeah.
All right, I'm going to stop the video because you won't be able to see the rest that I'm about to do. There's nothing else we're writing, but I'm going to show you some little tricks to help you remember this.
Hi, team. Wait, team.